Okay, so this is step 5. For step number 5, I already told you that the DHAP, oh, I forgot to write the name down here, DHAP, dihydroxyacetone phosphate, is going to be converted to GAP, GAP. So down here you can see something for me to help you remember the molecules. So first, acetone. What is acetone? This is the acetone, 3-carbon molecule that has a ketone in the middle. That's why it's a on acetone. So when acetone has 2 hydroxide group in there, it's called dihydroxyacetone. The hydroxy cannot end up in the middle because this carbon can no longer accept any more oxygen or anything. So this is dihydroxyacetone. So when you add a phosphate group in there or in there, doesn't matter, because the molecules is symmetrical already. So left or right doesn't matter. It becomes this dihydroxyacetone phosphate. So if I add phosphate in there, it becomes this. Okay. So DHAP, dihydroxyacetone phosphate, will convert itself to GAP with the help of an enzyme called triose phosphate isomerase. Triose phosphate isomerase. There you go, another isomerase. So these two are basically isomer of each other. And to convert between different forms, of course you use isomerase enzyme to isomerase that act on the triose, 3-carbon sugar that has a phosphate in there. Of course, the HAP or GAP, they both contain a phosphate in there, and they are 3-carbon sugar. 1, 2, 3, 1, 2, 3 with a phosphate there. Okay. And then I'll explain in details the chemical way how they convert to each other. So at first they have to go into an intermediate form, which is, you know, very fast kind of form. Between the two forms there's an intermediate. So what happens here is that the double bond here contains 4 electrons, right? Of course, double bond is just like 4 electrons in between. I mean, to form it, you need 4 electrons. So this electron jumped into here, and it forces 1 hydrogen to jump over there to form this. Okay. So basically, what happens is 1 electron from here jump into here to and then because this one now have 1 extra electrons, it affects the hydrogens. So this hydrogen will find its way to get there to become this one, and 1 extra electrons here will jump into here to create the double bonds. So when you have this one, you're gonna have this one, N-diol. So N-diol. In is a double bond. 2 all is oxygen. OH. And when you have something like this, it's not a very stable form, because when you have a lot of electrons here, which is negative, and oxygen here is also negative, they compete against each other for control of electrons, because oxygen is very negative, electronegative, and this one is also very negative in charge too. So they compete against each other. The result is that electrons here will jump into this position, and then causing this region to be imbalanced, and this hydrogen will find its way into there. We'll find a way into there. And the extra electrons will jump into here to form a double bond here. Okay. So finally, you have a glyceraldehyde 3-phosphate, GAP. Okay. So from one glucose molecule at step 1, you end up with 2 GAP at step number 5. Okay. Okay. I hope this part was helpful, and I'll continue with step 6, 7, 8, and 9 and 10 soon.